So let's start with VSMs and where they're used. Value stream maps, and the acronym is VSM, are used really as process views in both Lean and Six Sigma improvement initiatives. My introduction to value stream mapping actually happened through this set of books that you can see on the left here. Primarily, there's a book, this blue one, called Learning to See, which was written by Rother and Shook and is published by the Lean Enterprise Institute. These books do a fabulous job of talking about value stream mapping and how to look at it at the plant level, at the enterprise level, which is this book Seeing the Whole, and then looking at various detail aspects like making material flow, creating Kanban systems, etc. Value stream mapping itself is a process type of view. A value stream map is like a process map. In this picture, you can see that it's when you engage a group in drawing a value stream map, it's really a paper and pencil exercise. That keeps any tools away from getting in the way of the group, and this is really how an initial value stream map is done. Later on, when I talk about electronic value stream mapping that we're involved in, that's like a second step. Once you have a basic map captured like this, then a second step in making it electronic allows you to analyze it, share it, modify it, etc. So what's a value stream? The value stream is all activities required to take a product right from the order and then deliver it to the hands of the customer. So in the little graphic out here, I show an order going from the customer out to, let's say, a production control system, which has a forecast of supplier who's delivering material, and then the material results in finished goods that go back to the customer. One important aspect of a value stream that's good to understand is the idea that the activities within a value stream are made up of value-added and non-value-added components. And non-value-added is an interesting item. This is akin to waste. So non-value-added, the formal definition is that a non-value-added activity is something that the customer would choose not to pay for if they have the choice. So let me make that a little bit clear with an example. Let's say you bought a color TV, and it was delivered to your house properly wrapped with polystyrene and a cardboard box around it, and you unwrapped it, and you had that TV, and it was in perfect working order. If you had an option where they would deliver it to you without all that packaging, still in the same perfect working order, and just put it where it needed to go, you as a customer would say, okay, if I have that choice and I don't have to pay for that box and the polystyrene, I would choose not to. So that box and polystyrene would be considered non-value added. Similarly, if that TV was shipped from a distant location and you had the choice of not having to pay for the transport, you would choose not to. So again, transport, motion, etc. is generally considered non-value added. So value stream is really trying to depict activities and then also break out what the value-added and non-value-added components are. The basic concept of Lean, where you use value stream maps, is that if I can break it out, I can see the non-value-added easily, and I can start eliminating it, then I'll end up with a leaner value stream. And we'll get into that a little bit more as we look at the maps. So non-value-added activities are thought of as waste that we're trying to remove. So the goal of a value stream map, as you'll see, is to visualize the waste. So we're not looking at the details of actual activities. If somebody was drilling a hole, we're not asking exactly how the hole is drilled. We're saying, well, before they drilled a hole, how long did the material have to wait? After they drilled a hole, how long did it have to wait? How much did the material have to be moved? We're basically trying to analyze the waste, not the value-added portions in a particular process. It's a little different from your typical process map, is that it's focusing in on all the weighting and the motion and the defects as opposed to the work itself. So our goal with the value stream map is to visualize the waste. A lot of the methodology here, the Lean methodology at least, originates from the Toyota production system. And they've done a good job of identifying the different waste types. So you could look at a map and say, okay, where's the motion waste in here? Where are people moving around? Where am I seeing defects that are causing wastage? Where's overproduction? This is considered the worst type of waste. So this is producing more than your customer actually needs. Where are there things waiting to happen? These could be parts waiting to get worked on, etc. To draw a value stream map, a formal iconography has been developed. There's an icon language out there. And I'm borrowing the icons from this book called Learning to See. So this is a Shingo Prize-winning book published by the Lean Enterprise Institute. It was actually my first introduction to value stream mapping. And in the back of the book, there's a set of icons. And I just want to talk briefly through those. Now remember, with these icons, our goal is to visualize the waste. So one of the things that's represented on the icons is transport. So for example, trucks, planes, etc., as you see here. And that's because motion is considered waste. The idea of the map is to visualize what's happening, agree as a group that this is how things are proceeding, and then try and make database decisions on what to do next. So metrics are explicitly represented on the map to help you look at the data and then make decisions based on the data. They're actually written down right on the map. There's a couple of key flows that you'll find on manufacturing maps. The first is an information flow. For example, this could be the customer sending a forecast to production control, or production control sending an email request, let's say, to their suppliers. That's all information flow. If you think about it, there could be waste in the information flow. When the customer sends that forecast, it could be sitting in an in tray and get delayed for a day or so before it gets processed. So there's transmit methods associated with information flow, and there's queues and wait times associated with that flow. Then there's material flow. So once production starts, then this would be the raw material getting provided, going through the various manufacturing operations, all the way out to getting delivered to the customer. So typically for manufacturing maps, there'll be information and material flow. And there's icons available for both. Because the main goal of the map is to actually visualize the waste is explicitly represented via icons and variables. So you could have variables like defect percentage, and you could have icons such as trucks. This is a key icon. This is an inventory amount. This would be a queue, for example, if we're looking at information flow. One of the things you'll find with the Lean initiative is that a key outcome of a Lean deployment is process velocity. So if a process took a certain time to take an order and take it all the way through to a product, after you've removed a lot of the waste and you've done value stream mapping, you've done a Lean deployment, you'll find that that overall lead time is shortened. One of the things that's represented on the maps is a lead time ladder at the bottom of the map, and you're seeing just a piece of it here. It has an up, a hill, and a valley. The valley represents what are value-added components where the product's actually getting worked on. The hill represents non-value-added component, things like inventory getting to wait worked on, or things sitting in a queue, or other types of losses out there. So it's easy to remember with valley and value-added, and then the hills with the queues out there. And generally, the amount of value-added work in that lead time is summarized, value-added time, and non-value-added time. And people look at that ratio between value-added and non-value-added. And often you'll find that it's very low. It can be, value-added can be 1% of the total. And that's where the real opportunity for Lean lies. If you can visualize that kind of opportunity with a visual map, get everybody to agree that this is how things are happening and this is what we could do, it's a tremendous springboard for improvement. Once you draw a map with this icon language that I show here, then people look at that, you get some agreement on it, and then problems are identified, solutions are proposed. And in general, these are put directly on the map. Often these kind of starbursts, these are called Kaizen bursts, are used. And you write inside the burst what the problem or solution might be, and you place it on the map where it might apply. So the cool thing about that is that the ideas are right in the context of that visual map. It's not like a separate report, and you've got to go back and forth between the two. Okay, so let's look at a conceptual view of a product value stream map. You remember that I said that there are two flows. So here across the top is an information flow. And then at the bottom, here's the material flow. So here's the product going through the various manufacturing steps and logistic steps to go from the suppliers all the way back to the customer. Now, how are the value stream maps used overall within projects? They're really a piece of the continuous improvement cycle. So the way it works is in the beginning, you have to decide what is it that you want to draw a value stream for. You know, what's the scope of this value stream? And in the manufacturing world, that involves identifying product families that go through similar operations and that have similar cycle times. You then, once you've identified that scope or that family, you then draw a current state map of the value-added and non-value-added activities that are going from the customer all the way to delivering that product. Then you do the brainstorming with the Kaizen burst that I talked about and identify the waste on the map and what could be done about them, and you prioritize those. And that then leads to a future state map where you've identified what happens if you take some of the waste away. You then develop an implementation plan. This is often like a 90-day plan. Generally, you're working in quick 90-day cycles as opposed to kind of 2-year strategic type plans. And once the plan is implemented, then the future state map becomes the next current state map. And in that sense, this is a continuous improvement cycle. You're always going to have waste in any process. You're never going to eliminate it completely. So, you know, this just repeats itself after every implementation plan has been completed. So maps serve a critical kind of bird's eye view of the overall value stream and the waste in the value stream, and they serve this continuous improvement process. Okay, so let's look at how you actually draw a value stream map. As I mentioned, the starting point is generally a group session. Once you've identified which value stream you're trying to map out, you know, the start and the end points, you would identify people in that value stream. You'd make an arrangement for them to step outside of their normal jobs for 1-2 days and participate in this value stream mapping exercise. And then those people, with a facilitator perhaps, would start drawing a map. Typically, as I said, this is a kind of a wall exercise, a paper and pencil exercise, so that everybody can collaborate. There are no tools in the way. Sometimes little paper templates are used, post-it notes are used, etc. You can imagine how this works. And then you brainstorm what's wrong. You can use color-coded type gadgets to make sure that you identify the key opportunities. Once that piece is done, then often a second step is taken by the facilitator or the value stream manager, where they'll take that paper map and they'll clean it up and make an electronic version of it. Then they can do the analysis. For example, you see the timeline at the bottom of this map. When you add up these things, that gives you the overall lead time. They can look at the customer demand and say, okay, so if the customer demand is so many parts, how quickly do we need to produce a part? Do we need one every 4 minutes, every 5 minutes? That's typically called tack time in lean terminology. So there's the paper and pencil thing first, and then there's the electronic approach as a follow-up that looks at that, draws it up, analyzes it, comes up with some key numbers, draws some charts, and then allows you to make conclusions and helps with what to do next. So what I'm going to do for today is I'm going to assume that a map like this has already been done, and I want to go ahead and show you quickly a small example of how the electronic map is drawn so you get a feeling of the effort involved. I've pulled up the eVSM software, which is a little add-on to Visio. And within it, we've got all the value stream mapping icons. For example, things like the transport icons I talked about. If I right mouse click that, you can see that there's other transport types available, you know, international freight, all this kind of stuff, you know, train, etc. The blue icons basically are icon families. I said that inventory was very important and represents a delay. Just as transports is important for that material flow, transmit is important for the electronic flow. So here you can see the different ways of transmitting information. And you're trying to make these maps as visual as possible. So having iconography which you don't have to explain, which is very clear, it's obvious, is pretty important. Now, for specific application areas like manufacturing, these icons have been grouped together to form a template. So here's a template for manufacturing that we'll use today, and I'll quickly use it to draw a map. For this template, the rules are that the red icons have to come out first. This icon represents the customer demand. So I'm going to say the customer wants 200 items per day. And items refers to finished goods here. It's important to note the production time available per day. So let's say that this involves a plant. They're working a couple of shifts. And after taking out lunch breaks and things like that, let's say there's 14 hours available of production time per day. Now, if I know production time and I know customer demand, it gives me a rough idea of takt time. Takt time is basically available time divided by demand. So takt time is like the heartbeat of a factory. It tells me how often I need to produce a part to exactly meet customer demand. It doesn't say anything about the capacity, whether I can or cannot. It says if I was going to exactly meet customer demand, how quickly would I need to do it? Meeting customer demand exactly is important because if I produce too many, then I've got overproduction, one of those wastes that I talked to you about. If I produce too few, then I'm not going to meet customer demand, and I'm probably going to lose my supplier status out there. Let's draw a quick map. We're going to start with the supplier here, and the supplier is going to deliver some goods that go into a receiving inventory. I'm going to say the supplier is delivering coils. So here, generally with the value stream map, you start at the customer end, and you actually go and measure where you see piles of inventory, and you measure cycle times for operations and things like that. So that would have led to the creation of the hand-drawn map that I talked about. And now imagine you'd be looking at that map, and you'd be transcribing from there to numbers in here. So let's say I've got 300 items worth of coils. So coils to produce 300 finished goods. We typically indicate how the transport is happening. Remember, motion was one of the key wastes out there. So I'm going to use a finished goods arrow, and I'm going to indicate that this is maybe a train. Now later on we can add details like the distance traveled, the number of times this happens per week, the amount of material carried on the train, things like that. I'm not going to do that for right now, just to kind of keep it simple. Let's take the next activity. Let's say this is a stamping activity. And it takes about 6 minutes per part to do the stamping. Everything that says auto in here is going to get filled in by lean equation, so we don't really have to worry about that right now. And I'm going to say next that produces some work in process parts, so I'll call that WIP. And let's say there's about 500 of those. Again, somebody would have walked the floor and measured these items. I'm just pretending I'm transcribing from that wall map that I talked about. And let's say there's only one more step, which is assembly. And the cycle time here might be 10 minutes. But every 10 minutes is producing 2 parts. I'm going to give it a batch size of 2. And for our simple map, let's say that finish creates my finished goods. I'm going to call it FG for finished goods. And when they do the measurement, they walk the floor. Let's say they happen to see 1,000 parts sitting here. To some extent, the value stream map is sort of as a steady state map. So it's best to measure these numbers when you're in some kind of steady state, not when you're going through rapid growth or a rapid decline in production, because you'll get false numbers for these inventory numbers. I'm going to just move the customer a little bit closer out here, and then let's connect the finished goods back to the customer, and let's say that happens by truck. Now this really only represents half the map because this is the material flow that I spoke about. We still have to look at the information flow. Now I'm going to keep it fairly simple for now. I'm going to assume there's a control center here, and there's an electronic forecast from the customer. The jagged arrow represents an electronic forecast, and we can indicate that happened via, let's say, email in this case. And similarly, there might be some kind of electronic forecast going out here from here to the supplier, and I'm going to say that that's an integrated supplier, and that's a database linkage perhaps that's out there. The production control center could also be sending information to each of these stations out here to tell them how much to produce each day. So I'm going to show some of that information flow as well. Out here. So let me make the map a little bit narrow, and I'll zoom up so you can see this a little bit better. Put into full screen view. So far you can see that we've got the basic manufacturing flow for the simple example. We've got the information flow. We've identified the production time, the customer demand. We've got some order values here, which we'll calculate in a minute. A typical thing you want out of a value stream map is what's the lead time that this map will create, that this value stream represents. So there's a summary box here that we typically use for lead time. And then I'm going to talk a little bit more about what we mean by lead time in the context of this map. So the summary box has autofill, so we won't worry about trying to type in anything there. Let's imagine that this value stream was making green scissors. So the green scissors kind of started here, and there were, let's say there was a pile of green scissors, 300 green scissors out here. And then each scissor took 6 minutes to get stamped. Then it kind of waited in this pile here, took 10 minutes, waited in this pile here, and then got shipped out at the rate of 200 items every day. So if I was to make a red scissor, the red scissor would have to wait for this 300 green ones to get depleted. Then it would have to go through a 6-minute cycle here, wait for the 500 to get depleted, etc. And then the red one would finally come out at the customer site. That total time that that red scissor took, and having to wait in the queues, kind of first in, first out queues, that's what's known as the lead time. Now on this map, it'll actually be an addition of the non-value-added times, where it's having to wait for the inventory to get depleted, plus the value-added times where actually machines are working on it. Let's kind of do it let's do a basic calculation of what we think this time is going to be. Because the customer is withdrawing 200 scissors a day from this factory, and we've assumed this is kind of steady state, then this one, because I've got 300 scissors here, it's going to take a day and a half for this to get depleted. Similarly, 2.5 days here and 5 days here. So that's how you can calculate the non-value-added times. And then the value-added times can simply be the cycle times. Once in a while, there might be a non-value-added component within the cycle time, which we are able to record. But for right now, let's just do some of the calculations and verify that our kind of thoughts on that are accurate. So when we do the calculations, what happens is all of this data goes out to an Excel spreadsheet. It applies the equations in the spreadsheet. Here's the spreadsheet itself. The calculations are shown in blue. And then it takes the results of all of that and puts it back on the map. So just to do a quick check, as we expected, 1.5 days of non-value-added time here, 6 minutes of machining time here. If I look at the value-added percentage, this would be value-added of non-value-added, it's less than 1%. It's only 0.2%. And really, this is not atypical. It really represents a huge opportunity. And if you look at that time it took for that scissor just to go through the manufacturing flow, we really haven't considered the information flow yet, you can see that it took 9 days. Even though it had only 16 minutes work done on it, it took 9 days to kind of get through this flow. Now, you can see that the times on here are numerical, and they're not to scale. So now we can help the visual content of this map and show a scale diagram of that lead time ladder. Time reduction, as I mentioned, is a big part of a lean deployment. So I'm going to drag out a lead time chart and right-click that and go ahead and plot it. It's going to scan the map and plot a basic chart for us. So you can now see the basic components of that lead time. It's basically the inventories. Now, if the value added was actually significant at all, we'd see it. It's actually there between the gaps, but it's so small that we're not able to see it. And we can see that we've overall got about a 9-day lead time based on this number out here. So that's how long it takes a part to move through the system. If I was to look at the idea of capacity, can I actually meet this customer demand? Remember I said that takt time, here the takt time is calculated as 4.2 minutes. Takt time is completely a function of my available time and my customer demand. It says nothing about can the factory actually produce that, because it's calculated as the available time divided by that customer demand. So right now it's saying if I had steady state production throughout the full 14 hours of that day, then I would want to produce a part every 4.2 minutes, a good part every 4.2 minutes. Now, we can assess if we're actually able to do that in the factory by what's called a cycle time takt time chart. So this is another typical chart shown on the map. I'm going to drag it out and plot it, and then we'll talk about it a little bit. So here, the takt time line shows how often the customer wants a part. So the customer wants a part every 4.25 minutes of production time. But now the green bar shows the stamping can really only produce a part every 6 minutes. And assembly can only produce a part every 5. So here, what's going to happen is we're not going to be able to meet customer demand. And as you have bottlenecks like this, you get huge queue buildup in front of stamping and assembly. So let's say we take a look at this and we say, okay, we're going to add a third shift. So I want to go up here and say, we're going to add a third shift. We're going to move up to 21 hours a day. Now, when that happens, what you do is you have to recalculate the numbers, and it'll also redraw the chart, and we'll kind of see where we're at. So it's recalculating the numbers here. It's redrawing one chart there, and it should redraw the second chart there. Okay, so both charts are done. And now we can see that stamping is below takt time, but fairly close to it. So if we have defects and things like that in stamping, we may still have an issue out here. And we've got some comfortable distance between assembly and takt time. If this assembly is really low, then actually that might show that we have excess capacity. And maybe we can move people or other resources around to try and level out our production a little bit out here. Now, in general, when I look at a big map and I'm looking at the cycle time, takt time chart, there'll be many, many bars here. And after a while, it gets painful to have to look at a bar and then go figure out where on the map that applies. So one other way we can take advantage of electronic maps and help visualize this data a little bit better is by using visual gadgets to represent times on the map or any other data on the map and have them appear right next to that data. So for example, let's say I wanted to visualize these non-value-added times in that manner. I'm just going to delete these charts for now just to make the map simpler again. And I'll bring out a simple bar gadget and explain how it works. So here's the bar gadget. And let's color it red. I'm going to connect it to that data. Now what I've done is I've connected it to a non-value-added component. This is my non-value-added time because of that inventory. Once I do one, I can say, okay, well, go ahead and create the rest of them for non-value-added times by looking at this one. Use the same scale, put it in roughly the same place. And at a glance, then what that means is you can visualize the key data. Because one of the goals of value stream mapping is visualization. Imagine this map now being plotted out and being put on the wall. And you want people to understand this as quickly as possible and home in on the key opportunities. Using little visuals like this is really critical because then you can, you don't have to worry about the whole map. You can say, okay, if I want to reduce my lead time, maybe this is the first area I need to look at, or maybe this middle area with the width. And you can use, there's various gadgets like that. I won't take the time to kind of go through all those right now. So let's go back to the presentation. Hopefully what I've shown is that the goal of the electronic tool is to do a very rapid capture, rapid analysis, and visualization so the team can then go back and look at that electronic map and the charts and start making decisions about what problems do they see and what opportunities do they see for improvement. And they can start applying these Kaizen bursts to the map itself. And applying the bursts, of course, as you'd expect, is also fairly simple. They're predefined. Generally, we use this Kaizen burst for problems, and we actually use clouds for solution. It's good to separate out the problems from a solution because often you might have multiple possible solutions for a problem. And it's not a given that you're going to solve any problem. So you want to kind of create a portfolio feel to this, and in the end, decide which solutions you're going to apply next. There's an important prioritization, kind of low-hanging fruit aspect to this whole discussion. Okay. That'll give you a quick feeling of drawing an electronic map. Let me now go back to how does that tie into quality, especially with the group we have here today. And I'm going to go into different aspects of quality and look at some example maps and then talk about these items here. So first I'm going to talk about the impact of inventory and lead times. As I mentioned, the bottom timeline here is a lead time ladder. So this shows that if I was making that red scissor, how long it would take to go through this whole thing. And as I increase my inventory amounts, the lead time increases. So if I want to shorten my lead time, I want to be more responsive, then I can reduce the waste in the system. Inventory is just one type of waste. I could have queues, for example, that are involved in the information flow. I could have defects occurring on any of these processes that takes me a longer time to get through because I might have 10% defects. I need to make more. So all those different types of waste that we talked about earlier, you can visualize on the map. Now, inventory is particularly significant, though. It's a key tenet of lean that you want to reduce inventory, because having a finished goods inventory, a large finished goods inventory in particular, really can hide a lot of the waste in the system. So, for example, if I have 3 weeks worth of finished goods scissors just lying out here, I could have a lot of defects happening in here, but I'm always able to meet customer demand, so I never really have a high severity problem because I'm just supplying that from my finished goods. So I'm kind of hiding the waste that's out there. So, of course, if I have a defect and I have a lot of inventory, then the chances are that I'm also going to have a lot of bad inventory that I'm going to throw away. If the customer changes their mind, if it's a very a fast-moving industry and I've got a lot of inventory, again, I'm going to have a lot of waste out there. So inventory reduction is a really big deal in a lean implementation. So you want to have enough inventories that you don't run out, but you want to start reducing the levels gently. And as you do, it will expose the rocks in the system, it will expose the waste there, and then you start tackling the waste a little bit at a time. So you don't want a drastic reduction, but you want to start slowing down, reducing that inventory, and exposing those rocks and starting to attack them. It will drive that continuous improvement process. And inventory, like all the other waste, will contribute to that lead time. So as you reduce the waste, your lead time is going to get shortened. You remember I mentioned that a key outcome of a lean deployment would be process velocity and much shorter lead times. Okay, let's go back to the presentation. Now, another aspect of a long lead time is if you've got a defect, and let's say that lead time, that red scissor I talked about, took a month to go through that system. And let's say there happened to be a defect in the red scissor. So now, as a quality person, I'm having to track back and find out how that defect occurred, find out the root cause. I'm going to have to track some data that's a month old. So it makes that whole quality cycle, that essential cause and effect, root cause cycle, a lot more difficult with long lead times also. Plus, I think there's the customer's view of overall quality. The customer's view of overall quality would include a supplier that responds fast to change. So having a short lead time really does contribute to what a customer would think of as overall quality. Let's look at products defects now in the value stream. And I'm going to talk about a couple of impacts that they can have, again, by looking at a value stream mapping example. Now, in this example, I'm going to zoom in a bit. And you can see that assemble, I've added another data box here and said that assemble has 10% defects. When I do that, this cycle time, takt time chart updates. Recall that the red line was how often does the customer want a good part. The green was how fast can that machine create a part. So that machine can create a part every 0.1 minutes on this map. And the dark blue here is the effect, the time lost, if you like, because of those 10% defects. So what it's doing effectively is getting me much closer to that takt line, and it's actually reducing effectively my capacity to produce good parts, which is what the customer wants. Even more interestingly, notice that that defect happens downstream in assembly. We all know that if I have a downstream defect, I'm wasting actually all of the work that I created upstream. So if I have a 10% defect here, I actually have to make more parts here and more parts here. And you can see that in the magenta here. The magenta here is how many more parts do I have to make here because of downstream defects, basically because of this guy. And the blue is how many more do I have to make because of defects right in this operation. So you can account both for the effect of defects at a step and the effect of defects upstream of that step by using the cycle time, takt time chart. It's a standard chart that you'll see on many value stream maps. And you can see there's a very valuable way to look at capacity. Now, if you're the one who drew the map, maybe you're very comfortable with all these numbers and you can kind of look at all this. For a lot of the viewers, the first time they'll identify that waste or the problem area is by looking at the chart. And then from the chart, then they'll be willing to drill down in detail of, okay, let's look at the sharpen operation. Let's see what's going on. Let's see if you can really, have detection earlier in the cycle and not downstream, right in the assembly process, etc. So both immediate impact on the operation and impact upstream of that operation of defects. I go back to our presentation. Now, I've talked so far about the material flow side of the value stream. Let me kind of change tack a little bit. I'm going to look at a value stream that's actually a pure information flow and order processing value stream. So in this value stream, I've got a swim lane that's showing different organizations. Here's the customer, here's order management, and here's planning. And basically it's showing the process by which a customer sends an order all the way through the order being signed off. Now here the customer is sending the order. They generally send it to this order management department. But once in a while, there's an exception case where they actually send it through planning. So that's why we've got this kind of dashed line. So this is a standard process, and if you like, this is a secondary process. So, there are obvious quality aspects to not going through a standard process. And you can document those. Again, the value stream mapping is trying to say, okay, it's not like how would I like things to be, it's more documenting, well, how are things today? How is it working? Now here, there's another interesting quality aspect we can take a look at. So the order comes in, and it sits in a wait cycle. So there'll be a non-value added time corresponding it to it sitting in a waiting queue. And then here's the first activity where somebody gets the order. Let's say they find that it's got incomplete data or incorrect data. That would then raise is a query back to that customer. So this is actually a query block that you see out here. Some of the data blocks on there say, well, what % of time am I going to have a query? How long does it take to resolve a query? How long does a query sit in the queue, etc. What we've done is we've used that data to calculate how much effort there is in each of these activity steps. So for example, for order acceptance, this little bar here is tied to the FTE count, the full-time equivalent count. So about 6 people needed here to man this process to be able to handle the volume that's coming through. Now notice, a few more people here, about 13 people here, but notice that look at how much staff you need here just for the queries. You need a couple of staff just to handle queries here. That's pure waste. So yet another type of impact of defects. This could be due to not having a good, solid method of collecting information. If you allow information to get transmitted via kind of ad hoc methods like phone, as opposed to, let's say, a very structured method like a web form, then the number of errors, the number of queries that will result will be drastically different. So as people try and remove waste here, one of the solutions might be, hey, let's have a much more structured way of doing this. Let's not just allow people to have 5 ways they can communicate orders to us, etc. As far as visuals go, here's another lead time chart where you see wait times, and then you see different components of that total kind of 8-day lead time that you see. There's some grief times. We've chosen to call this kind of query grief. And there's a summary block here of the key data. So that gives you an example, a quality example of a value stream map that's a pure information flow. One more example I wanted to show you just to kind of vary things up a little bit. Final example I'm going to show you is in the logistics area. So let's look at a logistics map, and we'll talk about the 5 rights of logistics. This is a map I actually drew after attending a course on lean fulfillment that was given by LEI. And the author of LEI's book, Lean Fulfillment, was Robert Martichenko, who was actually the presenter for the course, so we were very fortunate. One of the very interesting things he talked about was these 5 rights. He had a value stream mapping example in the book. And they talked about in logistics, one of the things you need to worry about is these rights, the right quantity, the right product, going to the right place at the right time and with the right quality. And if you sum all these things up, they kind of give you the overall aspect of quality. And they kind of roll up into this perfect order execution. These are really 86, is just all these numbers multiplied together. Now, because the goal of the value stream map is to make all of this visual, we actually tied that number into this little pie you see out here. So if this was a full circle, that would be an absolutely perfect order. Now, at a glance now, you can kind of take a look at this and you can see that you've got an order execution problem here. There's a big problem out here. So you can kind of home in on what areas do I want to work on first. Similarly, we've used a gadget to represent this lead time. The lead time here is 226 days, and that magenta bar represents that. And if you look on the map itself, here's the contributions to that bar. You can see there's a big contribution out here. There's an inventory-related contribution out here. So you can start visually getting a sense of what's happening without having to dive into every small number. That means that more people can understand the map, more people can contribute the ideas, everybody can get on board with the improvement project and give it their best shot. Hopefully that gives you a feel of how quality ties in as is often represented on the maps. It also hopefully gave you a feel of the very different types of value stream maps that are possible. And then the idea that there are value stream maps for different application areas. You could have a manufacturing value stream map, and we were using a template for that. We also have templates for healthcare maps and service maps, and I think you saw the service map template, at least the final product of it, in what I showed you. Let me summarize, and then we'll be ready for Q&A. So in summary, I'd like to say that value stream maps are a critical part of a Lean Six Sigma deployment. They give you that bird's eye view that help you visualize the value stream for these key product families that you've identified and help you see the waste in all its forms. And with any improvement project, you're trying to get rid of the waste. And as you reduce the waste in any kind of lean deployment, you'll see your lead times decrease dramatically. eVSM, and I showed you a quick example of creating a map in that electronic tool, is really designed after you create that paper and pencil map. It's designed to simplify the capture, the analysis, all the number crunching, and the visualization. I showed you charts and gadgets of that value stream map. With that, I'll open it up for questions. As Ha mentioned, you would type any questions that you might have in that questions panel. And then I'm going to take a look through the panel and start answering those questions for you. So just give me a second to figure out how this whole panel is working. And let me have a quick look. Okay, there are a few questions out here. So let me... Okay, and I'll just pick a few. Somebody wanted the file, so we'll have the file, both the examples file that we had and the PowerPoint file all posted out on the website. So several people asking for that. So that will be on the ASQ website. And when I turn it over to Ha at the end, perhaps Ha, if you could confirm that. Slides are available. Yes, slides are available. How do you get the add-in for Visio, this eVSM software? You just go to eVSM.com. There's actually a free 30-day trial that you can download. Now, you do need Visio to be able to run eVSM, and you also need Excel. You can download, I guess, the trial version of Visio from Microsoft if you don't have it, but just go to eVSM.com. How much is it? eVSM is $350 per PC. The trial is actually full functionality, so you can do everything and play with it for 30 days. So that's where I would suggest that people start. How often should the VSM be updated? That's a good question. One of the great risks for VSMs, and I've seen a lot of those, is they end up as this kind of wallpaper. By making it electronic, by doing the calculations, by visualizing it, by getting people engaged, hopefully there's less of a chance of that. A lot of people update it every month. It's certainly not something that's updated every day. Having said that, we have one client who actually has the value stream map on a smartboard throughout the facility, and it gets updated daily. So, and they have gadgets tying into inventory amounts, key metrics on the map, so that everyone is aware of what's happening on the value stream. That's a little unusual, but perhaps with the electronic age, we'll go more and more that way. Let's see if there's any more questions. eVSM, what does it stand for? The E is for electronic. Now, not to be confused with E for enterprise. That's also used out there for enterprise value stream mapping. So eVSM is electronic value stream mapping. Let me see what other questions. How does one get training in the tool? Once you download a trial copy, actually do email us, and we'll get you on a free webinar that actually shows you how to use eVSM. That's easy for us to do. We run a webinar with GoToMeeting also. Is there an eVSM module for healthcare? Yes, there is. We have modules for healthcare, services, and manufacturing, and we're creating one actually specifically for logistics now. Is this a living document? I think I've already answered that. How often do VSMs be updated? It's not easy to read and understand when data is exported to Excel. Generally, you know, the data from the VSM gets exported to Excel, but then the answers get put back on the map. The map is your main communication tool, not the Excel spreadsheet. More and more with the templates, the Excel spreadsheet is really under the covers. You don't really have to use that to understand what's going on. You basically look at just the map. Just a couple more questions here.
Hey, let's have a couple questions when you got a chance.
Sure, go ahead.
Hey, you know, this is pretty good stuff here, but I'm looking for the benefits in two aspects. Number one, what are the benefits to the individual? What are the productivity for the individual to using this templates? And secondly is, what is the benefits to the corporation? If I want to deploy eVSM, you know, globally, every single plant, every single place around the world, what are the benefits for having a standard global deployment? So that's going to be, you know, benefits to the individual as well as benefits to the corporation.
Okay, yeah, that's a great question, and we've actually, over the last couple of years, we've been fortunate to complete a global deployment at a Fortune 100 company, a very large global company, and we've actually taken metrics from there, so I'll give you those. If I use a template, like that quick manufacturing template I used, and I contrast the speed of just capturing the map, doing the analysis, the visualization, compared to, let's say, using Visio by itself, it's going to be 5 to 10x faster than using native Visio or Excel or PowerPoint. So the person who's capturing that map is going to get that type of productivity improvement. Now, interestingly, the productivity improvement is not the main thing. The other thing they'll get if you're using a template is you get standardized variables, standardized equations, standardized charts. So when you're looking at a global deployment, probably the more important issue is that all these maps are standardized. You know, if people are writing their own equations or they're coming up with their own variables, you'd get very, very different looking maps. It'd be very hard to see the bigger picture. It's interesting, the standard work is a key part of Lean. Well, standard work also applies to the value stream mapping exercise and to people doing that work, and has all the same benefits that you see in standard work kind of overall. So it's a great question, and I hope that answers that for the group. Just a couple more questions. There's one that says, would you advise how VSMs follow a standard process, Kaizen burst, etc.? Generally, the way this is done, I show that continuous improvement cycle. You know, you're drawing a current state map, then you're creating the Kaizen burst. The Kaizen burst actually have additional properties like owners and dates and things like that that get exported out to an Excel spreadsheet. So the Kaizen burst then create an Excel spreadsheet that becomes a little project management thing. Let's say you're doing your project in 90 days. It becomes your 90-day implementation plan. There are a few more questions, but I think I've answered all of the main ones out here. Let me just have one last scan through. And then I'm going to turn it back over to Ha and kind of stay within my time limits. Okay, Ha, you've got it back.
Okay. Well, we want to thank you for all of you who take the time to attend this seminar. We hope that it's helpful to you. If you have any questions on the questions, please contact us. And again, we also want to thank Dilesh Patel for volunteering his time to show us, you know, pretty good stuff here. I think it's pretty cool. Once again, we will have the slides as well as the maps in PDF form. It's going to be posted in our website, asq.org, ASQ-auto.org. And we also have a recorded video for you to play. So if you want to take a look at that and watch that, that would be awesome. And if you have any questions, please contact us. But again, thank you for attending, and ASQ is the global voice of quality, and we hope to see you on February the 15th on a very important, very interesting seminar on problem solving and making a risk change. Once again, thanks a lot. Okay, good night.